Can you guys hear me okay? Yeah. All right, so my name is Vachuska. I'm the architect for ONOS as well as one of the developers, and today I'll just provide you with a brief overview of what ONOS is and some of its use cases and some of its roadmap items. So just to make sure everybody's clear, ONOS, i.e. Open Network Operating System, it's basically an open source platform for developing SDN solutions, SDN and NFV solutions for primarily aimed at service providers, but of course applicable at data centers and other ecosystems as well. So since it's aimed at building solutions for mission critical networks, it has to be designed with several tenets right from the onset. One of them is of course high availability, which is provided by a distributed core, so ONOS is distributed. In order to be able to support a wide variety of devices, it needs to be built with strong abstractions in mind in order to preempt vendor lock-in, because you can certainly write open source software that will lock you in also. Clearly, that's the idea, is to avoid that. And it needs, in order to be able to accommodate various use cases and modes of use, it needs to be able to be developed as an applications platform. It needs to be modular and extensible so that the service providers can tailor it to be able to accomplish whatever it is that they need to do. So at the base of the sort of the architecture is which is what provides high availability, scalability, and performance, is a distributed applications platform, which is in itself built on top of OSGI and Apache Karaf, which is another open source project available. It's a Java-based controller, I should probably mention. And on top of that applications platform is where we provide a set of network control and network configuration abstractions, and we refer to this as ONOS networking core. So this is basically the base minimum that you have to have in order to run ONOS. Of course, the base minimum is not necessarily always enough. In order to be able to do to accomplish things, you need to be able to extend ONOS with various functionality. And this is where the ONOS applications come in, effectively acting as ONOS extensions. You can think of the ONOS networking core and the distributed applications platform as basically a kernel. And the ONOS applications act as kernel extensions. And they can be both, the extensions themselves can take on many different shapes and forms. They can be precompiled Yang models, they can be drivers, they can be protocol libraries, and they can be full-on traffic steering applications. I think at the time of today, we have over 100 different ONOS extensions that can be loaded just by clicking a button in the UI or by typing command in the command line console. Now, of course, this is all within the controller kernel itself. But in order for the kernel to be able to interface with the outside world, we also have a number of sort of external adapters, be it a user interface to be able to interface with humans, REST API to be able to facilitate integrations with various orchestration systems and potentially other controllers. gRPC is also a variant of that effectively. This is something that's currently not 100% done, but we're working on this. And gRPC is effectively a way to be able to engage in high performance interactions between the ONOS or ONOS applications and other off-platform entities. As well as various other protocols. Now, of course, as with pretty much everything else in networking, you do also support command line interface for maintenance and basic administration and other things like that. So as you can see, so ONOS is designed as a modular entity. Now, it's not a monolithic entity in a sense that it's highly modular and it comprises of various, what we refer to as subsystems, each of them tailored to accomplish one thing and do it well. And then you can load these various subsystems and maintain them separately. Some of those subsystems are completely platform agnostic, such as various sort of horizontal services like application management, configuration management, storage, distributed systems management, and so forth. And some of them are aimed at providing the network control and network management domain type stuff. The point here is not to go over the inventory of these subsystems, but just simply to convey that ONOS is a modular and extensible entity. Now, it's also developed as a distributed systems in order for it to be highly available and scalable. There's different ways you can build distributed systems. ONOS is built as a symmetric one, where all of the nodes are software-wise identical, and they can do basically work done by one of those nodes can be done by any other node. So the work is completely migratable throughout the cluster. It provides logically centralized view. Even though it's physically distributed, all of the information is, and all of the APIs are set up so that applications have access to any information from anywhere in the cluster. And they can also exercise control over the environment from anywhere in the cluster. So it doesn't really matter whether this particular OpenFlow or P4 switch is connected to this node, and I'm running on that node. I can still exercise control just as if I was local to the switch. It's also dynamically scalable in order to be able to respond to changing workloads in the environment or potentially increasing or shrinking size of the network control domain. And it's secured, all of the distributed messaging is provided on top of one single messaging substrate, which makes it easy to configure, to penetrate firewalls, deal with NATs, as well as make it easy to secure. So that's just a high-level glance. In terms of our process lifecycle and development model, we are releasing ONOS versions on quarterly basis. So we're about to release our 11th version titled Kingfisher, which is 1.10. We're literally just like a week or 10 days from doing so. ONOS supports a number of, I already mentioned the extensions and applications and full-on traffic steering applications. Well, a lot of these applications were sort of matured in their own use cases and their own entities, and certainly Chord, that we heard about this morning is certainly one of those. So Chord is effectively a use case which grew out of ONOS and XOS, and has many different variants which ONOS supports, both for residential, mobile, as well as central. The central office interconnect. It supports packet optical use case, which effectively provides a multi-layer SDN network, which integrates both packet networks as well as optical domains. SDN IP as well as VPLS, those two work sort of hand in hand to provide SDN network as an autonomous system, which can be adjacent to either other SDN networks or potentially to classical networks, interfacing using BGP. And segment routing, which is a kind of a key enabler for Chord, which provides a spine fabric, which can achieve high utilization, high availability, as well as it can be easily controllable. So the current and near-term priorities for ONOS, and a lot of these things are either in flight or will be planned for this upcoming release, which is titled Loon. It's a set of Yang tools. With ONOS, we've actually developed our own Yang tools because we've looked at the landscape and established that we basically need to have some of our own in order to be able to get things done well. And a dynamic configuration subsystem. So we will be releasing Yang Tools 2.1 sometimes today or tomorrow. And we'll continue to work on a dynamic configuration subsystem in order to be able to have ONOS to be used as both a configuration and control platform. There is enhancements in UI to be able to help users visualize multi-region topologies. Because today's ONOS UI is very nice, but if you put up 2,000 nodes, it's difficult for the human to visualize and visually digest this information. And so we will provide a way to segment this information and categorize, basically create kind of a multi-layer hierarchical view through which you can zoom in and zoom out. In order to be able to cope with increasing number of applications and projects, we're going to be disaggregating our code base. We are starting on working on P4 and P4 runtime, as well as GNMI integration and support. One of the key features that we'll be starting with the Loon release, we've already scoped out how this is going to be done, will be in-service software upgrade, which is clearly something that's indispensable in order to be able to operate in production. And the idea here is that this will facilitate upgrade of an ONOS cluster one node at a time, without loss of basically without any outage in service. I've already mentioned gRPC API is basically a mechanism, highly efficient and, well, also reasonably standard mechanism for interacting between ONOS and outside entities. We're also, of course, spending time to enable and further support existing deployments that we have in research and education networks. There is an incubating effort on providing a network virtualization. Now, this is something a little bit different than what you might imagine from OpenStack. With OpenStack, the virtual networks that are created are sort of these amorphous blobs where they just have implied connectivity, and they're basically, you get a classical network with endpoints. ONOS virtual networks will be a little bit different in the sense that there will be SDN networks that you can control, and they will have no inherent connectivity necessarily unless you program it. Of course, there is a scheme for providing federation, which is either peer-wise federation between multiple different administrative domains, or potentially be able to administer a large administrative domain by segmenting into a sort of hierarchy of different control domains. And of course, as always, as a background activity, we're continuing to make sure that our build and release process continues to improve and be oiled smoothly. Now, how is a small team such as ONLab doing all of this work, you may ask? Well, we're accomplishing all of this clearly with the help of the community. And the specific mechanism that we're using is called Brigades, which is Brigade is a set of community members organized around a single goal. It may be a short-term goal, it may be a long-term goal, it doesn't really matter, but it's basically a group of people working towards a single objective. We initially started with 4 brigades, and we're going to be adding number of brigades. I think at this point in time, I don't know, David, we have what, about 8 or 10? Yeah, 10 different brigades. I'm not going to spend much more time on that, but I think this is a key mechanism towards our success. If you would like more information, please visit our wiki, where you can learn both more about ONOS, as well as about roadmap and about the brigade mechanism that we're using. And again, thanks to all of the ONOS community and our partners. And with that, I can open it up to any questions. Thank you. Any questions? Okay. Great. Thanks. Oh, is there one? Okay.
You mentioned initially about ONOS having the capability of working on common models within ONOS. So could you maybe just detail that a little bit? How do you come up with those models, and what's in scope for those models in terms of the capabilities of the devices and such? And how do you sort of maybe resolve that, if possible, across different vendors maybe, especially if there are differences in maybe the features or capabilities of different devices from different vendors?
Yeah, so we don't get terribly hung up on the models specifically. The there's different philosophies that one can approach this with, right? You can have an application that wishes to operate across many different devices and doesn't want to necessarily get locked into any specific vendor's model of organizing the control or configuration information. Or you can have an application that does want to be able to do that you want to be able to exploit a single disk particle, specific button that you worked with your vendor to provide you, right? And so clearly there's merits to both approaches, but generally, and with ONOS you can certainly accomplish either. But we certainly promote the first one, first and foremost, because that gives rise to portable applications that steers clear of vendor lock-in. And so for that, we primarily focus on abstractions. And if we do focus on models, it's effectively on standard models, which effectively standard model is a standard abstraction. And so this is where, for example, one of the, we've just released the Yang tools. We've already compiled Open ROADM model, and we're on the cusp of being able to pre-compile all of the open config models as well. That work has not been done, but it's going to be done very, very shortly. Definitely as part of the L release, but most likely even before that. So the focus is here on the abstraction, whether it's provided by Java API or whether it's provided by standard model. It doesn't really matter too much. Mm-hmm. Any other questions? Yeah.
One right here.
So, it's a dumb question. I was thinking that ONOS was at the bottom of the stack and doing the control of all the device as a controller. But now I'm seeing a slide where you show that you're doing federation, hierarchical. You want to be doing a horizontal controller to controller interaction, orchestration. So it's look like a lot of big expansion toward the higher end.
Well, so
why?
I should mention,
my question is, why ONOS decided to go and expand in this direction?
Okay, so let me answer the first question. So we haven't really decided that, the second part of the question, I guess. Specifically with the federation, example for federation, this is something that's been on a roadmap a while. We have not actually started that work directly, but we started it indirectly because with a research organization in Italy, they've actually started an ONOS, this was actually several years ago, already started their project called Icona, which is effectively a peer-to-peer federation of two different controllers. And they require it in order to be able to federate between multiple different administrative domains. So if you have a research network here, or whatever, network operated by one entity and network operated by another entity, and they need to collaborate in order to be able to do different things, you need to do it using fairly loose collaboration rather than integrating things in a hierarchical manner, for example. So that project was actually started by ONOS community. I mean, it was done with a little bit of our involvement, but for the most part driven by somebody else in the community. And it's remained a roadmap item since, because there's clearly merits and benefits to it. Now, it's quite possible that the same mechanism used for the federation would be something used for integration with ONAP, for example, or with some other orchestration entity. So the work will benefit ONOS and other parts of the ecosystem one way or another. Did that answer your question?
Yeah. Okay. Thanks.
Yeah, the question that I have is related to ONOS and ODL.
Okay.
And you have both under Linux Foundation, I
Yes.
believe. How do you per se determine the capabilities to evolve in each of these? In some carriers, again, it goes back to the question, the discussion we had this morning. We need to have an ecosystem, and then that ecosystem should be in a position to sustain. If you have two competing platforms under the Linux Foundation, how does the ecosystem spend the time for the long-term viability and sustainability of that particular product?
Sure. Okay. Well, that's a good question. Now, historically speaking, the two came from slightly different roots. ONOS was primarily primarily focused on control. The reason for that is because configuration is more closely affiliated with network management, which we've been doing for a number of decades. But control brings in a whole new realm of demands for performance and scalability and resiliency of the system. And in order to be able to accomplish this, we had to build the system with those things in mind from the get-go. So that's where ONOS came from. ODL, on the other hand, came from more of the network management space. And as a matter of fact, if you were to ask Colin, or actually Colin's own words at this most recent ONS, was that he's thinking about ODL it's not necessarily a SDN controller, but more of a next generation management station. And so it came from a slightly different background. Now, of course, in order to be able to control networks, you of course have to be able to manage it and configure it as well, which is why it's important that both platforms develop both control and configuration capabilities in order to be able to accomplish things, especially given the fact that the line between configuration and control is sometimes even fuzzy, right? What is which? So hopefully that answered the part of your question, which is why these are different. Now, of course, they are competing. There's no question in my mind that they're after the same goal. Now, of course, this one way to look at it is that this is good for the SDN ecosystem, that you have genetic diversity. Just like having an iPhone and having an Android is good for end users. I, as an iPhone user, benefit from the fact that Samsung and Google are around because they're putting competitive pressure on Apple. So it's in a similar way, the service providers are benefiting from these two platforms putting competitive pressures on each other. But I guess you could say another way to view it is that this is a distraction that we should consolidate, and that may certainly be something that's on the eventual horizon. But that's to be decided. But for right now, their focus still remains to be a little bit separate, and that's where we are.
While Saurav is setting up, maybe you can answer the question.
Yeah, a quick question, Tom.
Yes.
You talked about both disaggregating the code base as well as in-service software upgrades. So when you say, first of all, in-service software upgrades for what? The ONOS code base itself, or the system as a whole? That's not clear.
For the running system. So you imagine you've deployed a cluster of controllers that's operating your network, and it's a production network, and you now need to be able to move to a next version of ONOS and its applications. So in order to be able to upgrade it, rather than shutting down the entire cluster, you want to be able to designate a node, take that node down as if it was essentially a synthetic failure, upgrade its software, have that node come up, rejoin the rest of the nodes, which are still running the old version of software, and then tap on a shoulder the next node to be replaced. And then you keep going throughout the cluster until you've upgraded all of the nodes in the cluster and everybody's running the new version of software.
Okay.
So it's basically like a controlled cascading failure or progressive failure. But at no point in time you've essentially ceased your relinquished ability to control the network. That's how it's supposed to work. All right. Thank you, guys.